Hello students, I am Merphiya, Assistant Professor from Department of Renal Dialysis Technology and School of Allied Health Science, Salem, and today I am going to take principles of hemodialysis and briefly about what is hemodialysis, what are the principles of hemodialysis and some introduction about dialysis we can learn today's class. Let's see what are the objectives we are going to learn today's class. Introduction, principles of hemodialysis, diffusion, ultrafiltration. What is hemodialysis? What is dialysis? Dialysis is nothing but removal of substance, waste product from the blood is called dialysis. Today's class we are going to learn briefly about hemodialysis. Hemodialysis is a process which remove uremic toxins from the blood by using semi-permeable membrane under the principle of diffusion and ultrafiltration. In hemodialysis we are removing that uremic toxins and waste such as urea, creatine, potassium, those electrolytes we are removing from the blood and maintaining the electrolyte balance. Balance is called hemodialysis under the principle of diffusion and ultrafiltration. Principles of hemodialysis, diffusion and ultrafiltration. First we are going to study about diffusion. Diffusion is a movement of solute from the region of higher solute concentration to the region of lower solute concentration through the semi-permeable membrane. Here the solute means nothing but urea, creatine and potassium from the region of higher concentration to lower concentration. Higher concentration means blood, lower concentration means dialysate through the semi-permeable membrane. Mechanism is nothing but exchange. That means in blood there is a high concentration, in dialysate there is a low concentration. When the blood and dialysate solution coming equal concentration, still that this process is continue. That means the concentration gradients drives the exchange, allowing the waste products and electrolytes to the equilibrate between the blood and dialysate. This is the high concentration, this is the low concentration. Okay, high concentration means blood, we know that, and low concentration is dialysate solution. Here the movement of solute from the higher concentration to lower concentration. The picture was explaining detailing that what is the process of diffusion. Okay, from higher concentration to lower concentration, movement of particles from higher concentration to lower concentration. Next, factors affecting diffusion. Here 9 important factors that importantly which affect the diffusion. First, concentration gradient. Second, blood flow rate. Third, dialysate flow rate, membrane permeability, dialyzer efficiency, molecular weight, temperature, dialysate flow geometry, surface area of the membrane. Next, we can see that a detail about the factors which affect mostly in diffusion, and that a concentration gradient. The difference in solute concentration between the blood and the dialysate. And the large surface area increases the rate of diffusion. Here the solute move from the area of higher concentration to lower concentration through the passive diffusion. Passive diffusion means nothing but, for example, active diffusion means the process will continue without any changes. But passive diffusion means what? Which means when there is the need, if the blood having higher concentration, at the same time that dialysate solution having lower concentration, there we need that passive diffusion on permeability need. That time that electrolytes will move from higher concentration to lower concentration. So here concentration gradient is move through passive diffusion from blood to dialysate. The movement continues until the equilibrium reached. When the dialysate and blood reach the same concentration, the process will continue. Process will continue on both sides equal. When blood and the dialysate flow reaching the equal concentration, this process will continue. For example, it is an electrolyte adjustment. In simple word, we can tell that electrolyte adjustment. Blood flow rate. Increased blood flow rate increase the diffusion rate and thus clearance. Here when the blood flow, normally we fix that blood flow rate is 180 to 250. In normally we fix but somebody's we will fix that 180. In 180 there is a diffusion is comparing with the 250, clearance will be low, but when we are keeping that blood flow rate is 250, the clearance will be much better. and the electrolyte balance also good. Okay, that is called the blood flow rate. When the blood flow rate is high, the clearance also high, diffusion also high. Dialysate flow rate, increased dialysate flow rate increase the diffusion rate minimally and increase the clearance. When the dialysate flow is high, here the clearance also high, at the same time diffusion also high. Next, membrane permeability. The membrane with the large pore size allow increased diffusion rate of the small molecule as well as the diffusion of the large molecules. Here is nothing but here there is a many types of dialysers, F6, F8, and there is a lot of types. Okay, that time here large surface area have that high permeability. So in large surface area dialyser have large pores. So in that pores, that movement of solute, small molecules also can move easily, medium size molecules also can move easily, at the same time large size molecules also can move easily. So membrane permeability is a very important thing in diffusion. Okay, one of the important factor which affect the diffusion. Dialyser efficiency. High efficiency dialyser, that is dialyser with the large surface area causes high diffusion. High efficiency means nothing but large surface area dialyser have high efficiency. So here the clearance also increased. Here the clearance also good and better. Molecular weight. Diffusion of the particles depends on their molecular weight. Lower molecular weight waste product diffuse through the semi-permeable membrane very easily and middle molecules slowly and large molecules very slowly. Here the molecular weight, here the clearance, not only clearance, the movement of solute also depends upon the molecular size. So here the small molecule size can move very easily, but when the large molecule size solute will move it's very difficult to move through the semi-permeable membrane. So it is one of the important factors. Molecular size is an important factor which affects the diffusion. Temperature. Warm temperature promotes a faster diffusion comparing to the cold temperature. Yes, we have to maintain the proper temperature, which means 34 degrees Celsius. It is better clearance. If it is warm or cold, it affects the clearance. Certainly it affects the clearance, it affects the diffusion. Dialysate flow geometry. Counter current dialysate flow of the dialysate in opposite direction to the blood flow, and co-current dialysate flow is flow of dialysate in the same direction of blood flow. Counter current dialysate flow causes high diffusion rate than the co-current dialysate flow. Here in hemodialysis we use counter current dialysate. What is counter current? What is co-current? Here the counter current is nothing but in blood and dialysate compartment the direction of flow is opposite direction. Blood is opposite direction to dialysate. In co-current dialysate flow is same direction, so there must be clearance changes and diffusion also the changes. Counter current dialysate flow is better than co-current dialysate flow. In hemodialysis we use counter current dialysate flow. Ultrafiltration. Ultrafiltration is the movement of solvent from the region of higher concentration to the lower concentration through the semi-permeable membrane under the hydrostatic pressure. What is ultrafiltration? Ultrafiltration is nothing but in diffusion there is a removal of solute. Okay, urea, creatine, potassium, etc. Removal of solute. But in ultrafiltration here the removal of excess fluid. In ultrafiltration here we will remove the extra fluid from the body. Okay, ultrafiltration is the movement of a solute from the region of higher concentration to the region of lower concentration through a semi-permeable membrane under hydrostatic pressure. This process is selectively remove excess fluid while essential solute like proteins and blood cells are retained. Yes, here we are in ultrafiltration we remove excess fluid. What are the factors affecting ultrafiltration? First thing in ultrafiltration affecting factors means transmembrane pressure. Transmembrane pressure is nothing but this is we will observe or monitor in the screen of the dialysis machine, that TMP pressure. Okay, we all know that TMP pressure which affect the ultrafiltration transmembrane pressure. During hemodialysis, water move from the blood to dialysate in the dialyzer as a result of hydrostatic pressure gradient between the blood and the dialysate compartment. Here the blood to dialysate in the dialyzer, the excess fluid is removing from the blood to dialysate compartment by hydrostatic pressure. Only because of there is a pressure creating hydrostatic pressure which helps to remove the excess fluid from the blood to dialysate compartment. The amount of fluid removed is controlled by adjusting the TMP, which is difference in the pressure across the dialysis membrane. TMP is managed by dialysis machine. Yes, we already know that TMP is completely measured by dialysis machine. Next, dialysate pressure. Negative pressure on the dialysate side increases the pressure gradient, enhancing the UF. Yes, negative pressure, when the venous pressure is going negative, it increases the TMP, which means there inside the membranes there is a lot of damage and blood clot. Due to that, TMP pressure will increase. So we can find that inside something is fault, so we can adjust the pressure, so we can find or we can treat further. We can change the dialyzer or we can go for further treatment. Okay, just see the summary of the today's topic, hemodialysis. What is dialysis? A removal of substance or removal of waste product from the blood is called dialysis. Hemodialysis is that we are removing substance from the blood is called hemodialysis. Hemodialysis is a process which removing uremic toxins. What are the uremic toxins? Means urea, creatine, potassium. Principles of hemodialysis. There are two important principles we already studied, diffusion and ultrafiltration. First one, diffusion. Diffusion is the movement of solute from the higher concentration to lower concentration through semi-permeable membrane. Here is a solute is urea, creatine, potassium. Higher concentration is blood, lower concentration is dialysate. So clearly it is explained, the diffusion is removal of substance from higher concentration to lower concentration through semi-permeable membrane. There is a membrane between the dialysate and blood compartment which play important role in filtration. Mechanism, the concentration gradient drives the exchange, allowing the waste product and electrolytes to equilibrate between the blood and dialysate. Diffusion, this is the higher concentration and this is the lower concentration, movement of solute from higher concentration to lower concentration through semi-permeable membrane. Factors. What are the factors which affect the diffusion? Concentration gradient, blood flow rate, dialysate flow rate, membrane permeability, dialyzer efficiency, molecular weight, temperature, dialysate flow geometry, surface area of the membrane. Concentration gradient. Here the difference in the solute concentration between the blood and dialysate. Here the large surface area increase the rate of diffusion, and here the solute move from higher concentration to lower concentration through semi-permeable membrane. Movement continues until the equilibrium is reached and the concentration solute of both sides is nearly equal. Yes, here the electrolyte adjustment. Concentration gradient is nothing but electrolyte adjustment. When the both compartment, blood compartment and dialysate compartment coming to same concentration, the process will continue when it is needed. When it is a passive process, when it is needed, this the process will continue. That means nothing but electrolyte adjustment. Blood flow rate, increased blood flow rate have high clearance and high diffusion. And dialysate flow rate, when the dialysate flow rate is higher than normal, clearance will be high and diffusion also high. Membrane permeability, when we are using high permeability or high flux dialyzer, there must be a better or best clearance when comparing with low flux dialyzer, because high flux dialyzer, when we are using high flux dialyzer, small molecules also can move easily, medium size molecules also can move easily, at the same time high size molecules also can move easily. So here membrane size play important role. Dialyzer efficiency. High efficiency dialyzer, that is dialyzer with a large surface area, causes high diffusion. Molecular weight. Low molecular weight waste product diffuse through the semi-permeable membrane very easily, and middle molecules slowly and large molecules very slowly. Then next, temperature. Warmed temperature promotes faster diffusion comparing to cold temperature. Clearance is better, but when the body is too cold temperature, or the dialysate solution is cold in temperature, this will affect the clearance. So blood viscosity is important thing in hemodialysis. Dialysate flow geometry. Countercurrent dialysate flow of the dialysate in opposite direction to the blood flow. Co-current dialysate flow is flow of dialysate in same direction of blood flow. Countercurrent flow causes high diffusion rate than the co-current dialysate flow. Ultrafiltration. Ultrafiltration is nothing but movement of solute from higher concentration to lower concentration through semi-permeable membrane, which means here in ultrafiltration we remove the excess water from the blood, while essential solute like proteins and blood cells are retained. What are the factors which affect the ultrafiltration is transmembrane pressure and dialysate pressure. The transmembrane pressure is an important thing. When the transmembrane pressure is high, clearance also affect, diffusions also affect. There is a alarm, repeated alarm when the transmembrane pressure is high. So clearance will surely affect. So clearance also affect. There is no proper removal of fluid. Transmembrane pressure is managed by dialysis machine. Transmembrane pressure is shortly called TMP, is completely managed by the dialysis machine. The dialysate flow, dialysate pressure, negative pressure on dialysate side increases the pressure gradient, enhancing the UF. Thank you.